I'm Mike Scarpula, and I'm currently an associate professor of electrical engineering and material science. So I research especially compound semiconductors, and in a lot of cases my research is focused on their use in thin film photovoltaics. I studied material science and engineering as an undergraduate at Brown University, and then I also studied material science at University of California at Berkeley for my master's and PhD. And then before I came here to the U, I was a postdoctoral researcher at UC Santa Barbara, and by that time I had kind of specialized in the compound semiconductors. I've always been interested in science and engineering for as long as I can remember, and you know, it's one of those things my parents would talk to me about, like, hey, maybe you should look in engineering. I can think of so many times when you know, I was playing with my brother or friends, and what I wanted to do was spend the whole day building the apparatus or what we were going to play with, whether it was a catapult or a tree fort or whatever. And they got tired and went and played by themselves because I was still building the thing while they were trying to actually play. So it's been a long, a long time that I've known that this was kind of the right path for me. I was, as I said, doing a postdoc in California, and my wife and I wanted to live in a place that had a good quality of living, and preferably some place that had mountains, because we love hiking and mountain biking, skiing, etc. And I wasn't really thinking of applying for faculty jobs until the next year, but this position came up and I jumped on it, and the rest is history, I guess. I like when you can really make that connection with the students, where you can see that they're thinking and struggling with a concept, especially when they start to ask great questions back to you, and sort of they can see, you can see those lights go on of a new concept being solidified in their brain. I'm figuring things out and learning new sort of twists on the material every time I teach the class, even if it's the same class over and over. This course really aims to give you the solid foundations of how how the electrons and holes move around in semiconductors, and as a result produce the external observables that we see, like the JV curve of a PN junction or the gain of a transistor. These things really come from fundamental physics inside the semiconductors. And without that understanding, I don't think that you can make advancements. I mean, we can certainly repeat what others have done, but without knowing really at a deep level how these things work, I don't think it's possible to design the next generation of transistors or photodetectors or solar cells. What comes next? So we really have to dig in here in this class and get to know these fundamentals of device physics really well.